Hello everyone. Today I want to share a scaffolding approach that I use for teaching robotic programming to young children. We'll be using this little guy here for our demonstration today. Why rapid? And you'll see that in a minute. So my robotic training for the younger children revolve around the Duke program. They have the academic adventure, which is only one Saturday and actually about 6 hours of training really for middle school students. And then we have the Scholars Weekend, which is a Saturday and Sunday, and that more substantial, about 14 hours. Usually I have junior high student in there. And then we have the UGA summer camp, and 5 days, and not Duke Dip students, just anybody who is interested, 11 to 14 years old. The biggest instructional challenge was I had only hours available to provide a foundational knowledge and some practice of robotics programming. Hours, not days. So through several times, several iterations, I pretty much figured out that I need to pick and choose only programming concepts directly related to robot control. I cannot teach like a mini version of computer science 101. It just won't do. Uh, and then I had to use analogies during my teaching to see every life experience as much as possible. Okay, so this is the first programming session, and this is the result of the first programming session. And what we're going on next is it actually goes to step by step and kind of explain the reasoning or my rationale behind whatever step I do. So let's go up here. So this system here called the Robotics Dream System. The robotic is not, the actual robot is not that critical for what I'm trying to share with you here. So the actual time, of course, you need to show the kids how to use the software and where the menus are. But like we got it set up. And then in this particular software called RoboPlus TASK, it's manual driven pretty much as you start the program. And then we started out with only the very first statement to use it. And so we first say this program, which is essentially this statement, which is essentially a load statement or assignment statement to show them, yeah, key thing here, you can use it to assign a parameter or a variable. And let's say put it 500. That's roughly half the speed that the robot can do, let's say on the motor. So this one here is just showing students that, yeah, this is an assignment statement, and the key concept here is you have to read the code is from the right to the left. So 500 is saved into a parameter called speed, and there's nothing wrong with here, so we can download the code. So first, the system is set up, you had to turn it on. Okay, now you can download the code. And then usually after download the code, and then it just turns itself off to make the program. So the program actually get down okay. And then you can use this one here to see the program output. You can see in here there's no program output at all. So if you turn it on, it shows a little preview of the bootloader on the little robot here, which is show that's the controller name and all of that. But of course, there's nothing to show. Okay. So the next step is say the robot can run the program okay, but we have no idea of what's going on. So usually an easy way to see what's going on is we have a print line. And then we just print out the value of the variable called speed. There we go. It's still on, so I can download. And then now I go to viewing output. Boom. We run the program again, but now because we have this command, so we can see that, hey, it did print it. It did print out 500 correctly. So the next concept I want to show is hey, the sequential control. Essentially, you cannot just mix up any statement you want in your program and make it work. In our human mind, we can do it, but not on a computer world. So the next thing we do is actually going to take that one out and then reverse the order here. And then it's still on, so we download it again. And then we're going to show the student that, why does print 0 now? So you can see that we can ask the student about different, this is sequential control or logical thinking, I guess, sequential logic thinking. Tell them, yeah, because now you print the line, the speed first, so therefore it had nothing in it, so therefore print 0. And you did set it to speed to 500 later, but you didn't print it, so therefore it won't show anything. So this is just to teach students sequential control. All right, so the next thing we did is, let's bring it back to normal here. So we have that visit. And then for our next is, usually one thing I found out is this is a simple robot. It had 2 wheels. So during the building or the construction, very often left and motor may not be connected correctly to the robot. So this step, usually I want to show them how to move a motor, how to control motor. Also, we're going to check on the construction. So how to turn on the motor. So now we're ready to show how to turn on one of the motor. And they can be port 1 or port 2. So we'll do this experiment here, let the kid explore on their own. So let's show them how to do that statement. So essentially, we have to turn on the gear motor at port 1. We're just going to try port 1 first. We have to tell it which way to turn and how much speed. So we're going to go into motor value. And let's just say counterclockwise, it doesn't matter. And then, of course, over here, it's going to be the variable speed, which we had previously set to 500 already. And then we're ready to go again. Okay, the output window. The program is in. Let's see what it does. 500, and then boom, nothing. We did turn on the gear motor at 500, but you can see nothing is happening. And then we have to go and explain that, yes, you did turn it on, but then the program exited right away. So when it exited right away, then nothing, the motor didn't have the time to turn on at all. And then we introduce is, in order to make a motor on, you had to turn it on, and then also you had to tell it for how long. So here the analogy I use is, just like you use a microwave oven, you want to turn it on to heat your food, but you also you set up the power, right? Which is this statement, but also you had to tell the microwave for how long. So that involves a timer, which is another assignment. So you kind of set up your timer. You use a high resolution timer. High resolution timer is set up in milliseconds. So 1 is only 1 millisecond. So let's say we want a second of it. So then say a second and a half, let's say 1500. Fine. So, and then here the same way is with the microwave oven analogy is when they start the system, they can watch that the timer goes down and then to 0 and then it quits. So we're going to show the same way, and you achieve that using this while statement. And as long as that counter is still bigger than 0, that means it haven't reached way down there yet. There's a timeout essentially, and then it's okay. So that's what we added. And then now let's see. So let's see. Power's still on. Let's download it. Okay. Let's run it. Okay. So let's try it again. Oh, I just turned it off. Sorry. Turn it on again. Okay. So it was going in a way forward. So therefore we had to check. So, and the control where we were telling it to go counterclockwise, which is here, which is related to the motor here, go counterclockwise, which is okay. So we know that port 1 is on this side, and counterclockwise make it kind of go forward. So we figured that one out. This is a point when, depending on the student, they're gonna find out either they swapping port 1, port 2 over, or counterclockwise and clockwise got swapped around. Basically, construction mishap. And usually I tell the student, no, that's okay. Your body is just special. So what you need to do is you have to figure out whatever makes your bot work a certain way and stay with it. Your program may be different from the instructor program and maybe different from the other kids in the class, but it's fine as long as you know that's how your robot works. It's okay. There's nothing right or wrongly to do that, but because if you assemble a certain way and you control a certain way. So therefore, we figured out this one is port 1 and counterclockwise going this way is good. That means what? This guy is going to be port 2, and it had to go clockwise in order to go forward. So that help with that. We know what we can do here. So we know we're going to insert the new statement here. Actually, you can even show them how to cut and paste Control C, Control V in here. Except we had to make sure we change it to port 2. And then also, let's go clockwise now. Yeah, assuming that, we want the robot to go forward now. And then that's it. And then we make sure it's on. Yeah, it's on. And then we download it again. So everything is okay. We don't really need this one because if we want to see verify the 500, because it's just going to move on it. So that's the whole point. Okay, so here we go. Didn't move up for 1.5 seconds. That was pretty fast. Let's turn it off and then turn it on again. Zoom it goes. Okay, and then here is the interesting point that probably most people haven't used is what I do is I use the main program here like an experiment playground. I create my code. I want to make sure everything working here, and then I use function. But function, I plan to use them as like a place where you keep all your good work. You've done it, it's working. You need to save it. Okay. So what I do is say, hey, pretty much this section of code here worked pretty good for going forward. We know this is work for going forward for 1.5 seconds. So let's save that work now because we want to go on and program how it to go backward. We want to program how to go left and right, that sort of thing, the basic move. So what it does is say, okay, there's a way to do that by creating function. Essentially, once you get a bunch of code that you know is working, and you're going to use a lot, let's save it. So we create function. So this is a little bit different, as you know. Function, if you take regular computer programming classes, function was used really to create a lot of the programming, which is fine, and we are still doing it. But I think this is an easy way and in a way, maybe a sneaky way to teach the younger student is, hey, you use it to save the good work you've done. So we don't get into more abstraction discussion about, models, programming efficiency, that sort of thing. We're just gonna be straight, kind of be practical about it and say, okay, so these two are working good. So let's save it. and move him here. So we have a piece of code that worked for forward very well, and we got it done. Okay. And then we go back to the main program. We say, okay, now let's say we want the program how to go backward. And of course, the kid's gonna figure out real quickly, and all you had to do is just switch clockwise, counterclockwise to clockwise, and clockwise to counterclockwise. So we do that. Flip that around. Run. Okay. Or else we don't need it. And you just turn it on and see what it does. We should go backward now. Here we go. So we'll say, great, this works. Therefore, we can save another function as another function. So we create a function. Backward. And then once again, we made some good work. So we're just going to save it. Okay. And then, of course, let's make it turn left. Oh, and then we can still discuss about, oh, how do we mean turn left? So let's say turn left means going this way. So this way I have to go clockwise. And this guy had to go counterclockwise. So this is going clockwise. And this one had to go this way. This is also clockwise. So back to theory. Let's see if it works. So with this new piece of code, it should hang a left for about 1.5 seconds. Here we go. So let's say for left, we don't really need to go for 1.5 seconds. So we could change that to only 1. So now we're good. So we're going to create another function. Now we go turn left. And then this piece of code, still good. So we're going to save it in here. And then of course, just to speed up a little bit, here we go this way. Both of them kind of clockwise, of course. It's gonna go right. For 1 second. So it did that. I can spell today. So there we go. And then you probably can start seeing now. So now that I have this all function, you can see that, hey, guy, what? I can make it. So I can call them. And then we can say, oh, now that you have these function or this little piece of code that work real well, you can create in the main program a bunch of behavior that is more complicated. So for example, and then all you do is just show them the other side of the function is called call the function. So like for example, let's say, oh, you want to go forward first? Okay, let's go forward. And then we want to hang a left, let's say. So therefore, we're going to choose left. And then we want, let's say we want to go backward. Okay. and that's fine. And then I just realized something here too, is we don't have a stop. So what we can do is we can create a function called stop. And then say we stop for 1 second also here. And then basically stopping means just the speed is 0. So we're just going to put a number here instead of the variable 0. For 1 second. So like for example, we can do turn left, turn right, and then we'll stop here for a little bit. And then let's go, and we can cut and paste here. And then we can go forward again, but we want to turn right this time. And then we're going to do a final stop here. Okay, so you can see that within a few minutes you can teach lots of not complicated stuff, but at least a fair amount of structural and basic programming concept and structure, and the kid would love it, and they can understand all of it. It's fairly straightforward, and we use it to based on the everyday life. And we just have to not to think like a computer science 101 course, but be creative and adjust to the knowledge and the